Fine. Twitch doesn't think so. Come on. There we are. Hurrah, we're online. I'll go tell the world about it. Streaming. Oh, my cable is in the way. Move. Thank you. Streaming game dev. Gonna work on spaceship stuff. Paste. We'll hop on over to here and paste it here too. And then we'll wander back over to here. Sorry if I'm a little bit slow. My bus was an hour late. Elbow Etchy's already here waiting. Hello. Sorry you had to wait an extra 15 minutes. I left work early to make sure that I could get home on time. And the bus before the one I normally take didn't show up. And then the bus I normally take didn't show up. And then the bus after that was 10 minutes late. So, I'm annoyed. But that shouldn't interfere too much with my plans for today because I don't have any. I'm not really sure what I want to do. There are a couple of things that I do want to do, but I'm not sure which one I should do. One of the things that I should do is these mechanisms I was planning to build, this ship, isn't working out. And it looks like I'm going to have to change the way I'm doing things. And that's fine. I have a couple of ideas for how to do things that's kind of a crossbreed between how I was doing things in the original Galactic Line and this sort of greebled system. And they're not bad ideas. I tested them out, and it involves just some texture work that gets faded. But basically, I want to have these parts properly UV'd and stuff like that, and I'll fade them. Another thing we have to do is build more debris. Our camera is starting to feel good, but it needs some more work before it properly feels like it's awake, you know? So it's just starting to feel like our camera might be getting to the point where it might be usable. And there is our collision grid, telling us helpfully that we are about to slam into things. And in fact, we are. Congrats. Another thing I've got to do is fix the nav system, because right now, flying up really screws up our navigation. Let's go ahead and do that now. There's no reason to have that still be broken. Oh, hold on. The traffic is loud as hell. Give me a moment. So, storm weather is here, and funny thing about storm weather is the paint in this room apparently cries. There's some kind of problem with it moisturizing in storm weather. The only thing that really matters about that is that all of my soundproof panels fell off the walls, like all of them. So I think I'm going to have to just bite the bullet and stick pins through them into the walls, because tape does not stick to these walls when it gets wet. So if you hear some extra echo in my voice today, that is why. Nav. We were working on the nav. Let's go work on the nav. So here we have our ship control. And the key to our ship control is our navigation reacts to how we move the mouse. But right now, it doesn't understand that up. It still thinks that up is special. So we're going to fix that problem. So, if we take a look here in the up, that was loud. Everything's going to be a little bit squeaky today due to the incredible amount of moisture in the air. We didn't get hit by the hurricane, but we sure got hit by the rain bands. So here we've got horizontal, here we've got vertical. Those are strafe. We're looking at the mouse. Here it is. X equals mouse, X, Y equals mouse. And then here what we're trying to do is, we already have some rules trying to figure out what the hell's going on. These are not working out. We're going to want to try and figure out what we're doing here. So in order to do that, these rules are the ones that are bad, and we're going to go ahead and just remove them from possibility here. So I'm not 100% sure that this is the right way to do things, and I think what we may want to do instead is have it move relative to the ship up and ship right for a couple of reasons. But let's give this a shot and see whether or not it feels good. Oh, and if anybody has any questions or anything, feel free to let me know. By anybody in this case, there's only like one person watching, but later on this goes up on YouTube. There's lots of stuff that I'm doing in this game already that may not be 100% clear. So if you have a specific question about how I'm doing something or what I'm doing, I'm happy to answer it. Yeah, so here you can see that it's getting real foggy. That's not how it's supposed to control. So there's definitely some issues when it goes vertical, which is quite strange because this should be rotating around the pilot ring dot up and the pilot ring dot right. But instead we're getting some serious, like, I don't even know what to call it. It's just damage. So if we look straight down, for example, and then we try and move, you can see how that's left and that's right. That makes no sense because the pilot ring dot up should be that the way those arrows are pointing. So why is it going off in that direction? That's not left. That's like up and left, as if it's orbiting around something. Now, obviously, the pilot ring dot up is skewing as we go vertical, but it seems to be turning into something useless because that's supposed to be left. I'm moving the mouse left right now. Does that look like I'm spinning around the up axis of the pilot ring? Well, maybe I'm misunderstanding what the pilot ring is. Let's take a look. Pilot ring, here it is. So if we look at the local coordinate system, the y-axis is up, I think. Nope, we're looking at the z-axis here, yeah. So there. That is the z-axis, but I don't actually know. Hold on. This is all in global. Let's switch it over to see local here. Local position z. So that is... Really? That doesn't seem like it's along any axis. So this is how we are supposed to see it. And z is that way? Local? How is that local position z? You know, the problem is that we're working off of what the... no, because local position should be... Oh, I'm an idiot. Local position z is global position z because this isn't something that's attached to another object. It's free-floating. I've been assuming that it's attached to, you know, the child of the cockpit, but that's an illusion. It's not. It's floating in deep space. And that means that the z should still be off to the side. Or, you know, it should be... The local z is not the same as the local position z, because the local z is applied after local rotation. So this should be up, and this should be right. And for some reason, that's not what we're seeing here when I tell it to rotate around these. Is it because this takes a couple of variables here? Why don't we go ahead and just make this vector3.up and then tell it to do it with a local coordinate system. And then here we'll take vector3.right with a local coordinate system. Now in theory that shouldn't change anything, but I was seeing some weird behavior and I'm not sure what's up with that. So we're going to be real explicit when we're testing this shit out and try and make it so that it doesn't suck. So we're now pointing pretty far down. Let's try and go left. So left. So that fixed it. Okay, so I think what the problem was is that their idea of transform.right and transform.up were broken in some way. That's kind of strange, though. I wouldn't expect that to be a problem. But whatever the issue is, I have now fixed it. And if you see, I can actually spin over so that we are totally upside down relative to our original position. And our version of up remains up. So this is the same place that we started, except for now we have turned completely over. And that means that I can finally add in our rotational keys. Now, by finally add them in, I mean I already added them in and then I removed them, so now I get to put them back in. It's called spin. I had to look up the name of that, so x equals input.getAxis spin. If x does not equal 0, then pilot ring dot rotate, rotate, and then we'll make this vector3 dot forward. That's not how you spell rotate. Vector3 dot forward, and then we'll call it x times time dot delta time. We'll have to have a value there that changes, but that's true of all this shit. We'll have to come back later on and add in all of the responsiveness values, but this will rotate it 1 degree per second, or 1 radian per second. I think it's 1 degree per second. And that's obviously too slow. Let's go ahead and multiply it by 90. Magic numbers. So now we should be able to spin. And now that we no longer have that global up, you can see that our spinning works fine. By our spinning works fine, I mean that these guides spin, but the ship no longer spins to match them because I disabled that function back when I was having issues. So we can go ahead and make the ship spin to match them. And I think that I did that in this area here in align. Yeah, you can see how this is all like that. What we're going to do is we're going to try to make this ship spin so that it locks up. Now there's a lot of different ways to do this. The most obvious way would be to use the same values that we're using for moving and turning. If you're maneuvering quantity, I mean this is a maneuver, right? But I think what I'm going to do is I'm going to hard code it. And the reason for that is because I think that you should be able to spin your ship fairly rapidly. Just from the standpoint of your brain, I want you to have no problem spinning the ship. Peter Nerlich says, oh, hi. Yep, hello. I'm a little bit late today, and I also just cracked my knuckles straight into the mic. Sorry about that. So what we're going to do here is, this is when we rotate our ship towards its new heading based on the maneuvering quantity. But you can see that this this moves towards the heading rotation. The heading rotation is defined here as the look rotation of the pilot ring forward and the pilot ring up. So in theory, this should be aligned with our intended up, but the problem is that rotate towards doesn't give a shit about your intended up. So it's ignoring our intended up. It's only caring about the forward, as far as I can tell, because this heading rot should have the proper up in it, and it just is not being properly matched somehow. So let's take a look here. Quaternion.rotate towards. And Peter Nerlich just got in. So I think that what's happening is rotate towards uses this from to rotation, which takes vector 3s. So I think that what this does is it converts the from and the to into vector 3s. Or at least it converts the 2 into a vector 3. What we need to do is have this quaternion.look rotation, and then what we'll do is we'll come up with the current ship.transform.forward and the up angle of our heading. So what's it called? Pilot ring. Here we go. And we say ship.transform.rotation equals that. And that will keep our up locked to the pilot ring's up, regardless of what else happens, and that'll be instant. So if we spin now, you can see how that spins real fast. That might be a little too fast. It's not a hard thing to change, but one thing we do want to change is that right now it's backwards. So we're going to want to flip that axis upside down. And it's also a little bit too fast, so we'll go ahead and make it 60. Other thing we're going to do is we're going to go over into our spin element here. And we're going to give it a gravity. Now, gravity is how quickly it moves towards 0, whereas sensitivity is how fast it moves towards 1. So what we're going to do is we're going to change these both to 1. And the reason for that is because that will make it so that we have some slosh in our rotation that doesn't require our ship to have any slosh programmed into it. You feel that? How it speeds up for a second and then it speeds down for a second? That might actually be a little bit too unresponsive. So we're going to go ahead and make that a 2 and a 2. And that should allow us to get that nice feeling of heft, even though we're not simulating anything. We're just kind of letting the players spin as they like. But I think that that's going to be a lot better in terms of making it work. Now, the problem with this approach is, of course, that our ships don't have a clear up anymore. And that means that it's very easy to get lost in these levels. Now, in the long run, what we're going to need to do in order to make that not suck is we're going to need to have a system where we have some kind of markers that bleed through the rest of the world and show up like a HUD. Now, the question is, do I want those markers to be UI elements, or do I want them to be some kind of shader that only shows up it shows up through things, some shader that has a high z-axis. I can also use another camera, which is a trick I've used before. If you put a camera in front of your other cameras, then that's all you really need to do in order to get something to show up first. You just put it on its own layer and have the camera render just that layer. But that is an expensive proposition, and I don't know whether or not that would work in terms of the things I'd like it to do. I think it's better for us to use some UI elements, some 2D HUD elements. So that's what we're going to do now. We're going to go ahead and put in HUD elements. Now we have a canvas called HUD. It's where we put our message box. We're going to need to create a new kind of prefab, which will get assigned to a location in the world, and then we will have that track on our screen properly. Now, what we really need to do is have something pretty. But I don't have anything pretty built, and I don't plan to build any art today, so we're just going to go ahead and fake it with some of the basic built-in crap. That's a canvas. I don't want a canvas. I just want a panel. We're going to add in a canvas element, a canvas group rather, because that will allow us to scale the alpha, and that's going to be a good way to do things. We don't need it to be interactable or block ray casts, and we also don't need it to scale. It's just going to have the right size right from the start. We're going to want it to center itself, and we'll give it a width and a height of something reasonable, like 100 by 100. And what we can do is we can punch out the center so that it's a grid. Maybe this is 60 by 60. Even smaller is fine, 40 by 40. And when we punch it out in the grid, this is sort of a stand-in for what we're going to need to do in the long run, which is to have it be something that you can there we are. Have it be something that's pretty. We'll have like a spinning disc or something, but we don't have the art assets for that right now, so we're not going to do it. We're just going to use this. Let's make it an input background because those are less gray, and we're going to want some text. So let's add in a text box and put it underneath. Oh, that's not what I wanted to select. Fell through there because I was on the wrong selector. There we are. And what we're going to do with this text box is add in an automatic content-aware fitter. We'll center this, and we'll make it so that our horizontal fit is the preferred size. That way this text box will always be the right size for whatever text we put in it. We're going to have a background that's mostly black, so you'd think that this might be a good idea, mostly white text. And it might be, but the thing is we actually need to have another panel in here because you don't want to have it actually, we either need to have two text boxes or we need to have a darker background against this text box. I think that two text boxes is prettier, so I guess that's what we'll do. We'll just have two text boxes, and one of them will be offset slightly. So, -1. And -29. There we are. That's too much. -30. And then this one will be black rather than white. And we'll put it in the back. Not really feeling it. Is there actually a drop shadow function? I don't think there is. Sorry, I'm just thinking about how to make this show up, and I think that's probably fine the way it is. Another thing we can do is we can always raycast through the text and set the text color based on whatever is directly behind it in the game world. Most games use text that is some color that you'll never see in the game world, like bright green. Let's try that out. Let's give it the same basic idea as the box, make it this green color, and that should work, right? So this is going to be our radar marker. And we're going to go ahead and create a new script for our radar marker. Now this is actually only a small helper script for this part of the radar marker, because this is going to be a generic track on screen script. So we're going to call this world to camera tracker. And we're going to drop that onto our radar marker. There we go. Now the world to camera tracker will take a transform, public, transform target. And then every update, we're going to go ahead and move ourselves to wherever that target is relative to the main camera. So we can either specify a camera here, or we can just assume that it's going to be the main camera. So that's what we're going to do. And we're going to do that using a very simple getter and setter that will optimize our call so that we don't call the very expensive camera.main every single time. Oh, and here's a fun trick. Make this static, and we only search for it once, and that's great, no matter how many trackers we've got. So now we say if camera, if not camera, then camera equals get, or equals camera.main. That's an interesting problem. Return camera. Why is that if? Oh, because I forgot to put the get. You gotta do things right in order for things to work. All right. So down here, what we're going to do is we're going to say that vector3 pause equals camera dot world to screen point, and then transform dot position. And then what we say is that our position should be that position. The problem is that right now we don't know what our transform is. The transform, this, is a 3D transform, and just setting that value won't quite work. We don't have a built-in rect transform fetcher for some dumb reason, so we're going to do this manually the same way that we just did it. Rect transform RT, and then we'll just say public rect transform RT get. And Nerlich says, oh yes, I just figured I can get some work done while watching your stream since you don't have any music or background soundscape. He does sound design, so it makes it difficult to listen to sounds while working. Yeah, as I mentioned a little bit earlier, there is a rain bands from the hurricane are hitting us. We're not anywhere near the hurricane itself, but we're still getting wet, and that has made all of my soundproof panels fall off my walls because the tape stops holding in the wet weather, it turns out. So if you hear a lot of annoying echo, that should be gone by this Sunday. I'm going to use pins and properly stake them to the walls this time. But just so you're aware, yeah, if you're wondering why the hell this guy sounds like he's talking into a box, it's because all of my beautiful panels fell off. Like all of them. It's actually pretty impressive. They just all fell off. I was looking around the room, like verifying, yep, they're all on the floor. All right, so if not RT, then RT equals get component rect transform, return RT. So what we're going to need to do in order to do that is to say rt.anchored position or get local corners or pivot or rect. All of these things we can set, but notice that this anchored position is a vector 2. We can set an anchored position vector 3 as well. It's up to us whether or not we would like to have it convert the vector or not. It doesn't really matter. We'll go ahead and just set the anchored position 3D like so. And that should be all we need to track any given object. Peter Nerlich says that it sounds pretty decent. That's good. I can hear the echo pretty badly. So to me, I'm like, oh, ugh, ew, yuck. But if no one else can hear it, that's not too bad then. So what we're going to do is we're going to assign this to track an arbitrary object, like say that. So let's go ahead and select ourselves some debris. These are the debris. There is our displaced anchor. That'll work. Drop it in. Hit play. Boom. So now if we look down, oh, where is it? So that didn't work. Well, it looks like when we set our Z position to -9,000, it didn't much care for that. So maybe we do need to make it so that it's a 2D. Anchored position equals vector 2D. Pause. Yeah, there we are. That should automatically chop the Z-axis off. But I'm not sure whether or not that's actually going to work. Yeah, you see that flyby? There, you see that? It's not in the right spot. Not anywhere near being in the right spot. That's interesting. What have I misunderstood about how these systems work? Well, let's go ahead and just try and set the transform position to it. So transform.position equals vector 3, vector 2, pause. Those casts will flatten out the Z, so we won't have to worry about that. Nope. Am I using the wrong function here? I must be, right? Camera.world to screen point transform.position. Oh, idiot. Target.position. You idiot. You absolute numbskull. I was telling it to set itself to its own world position. That's why it was flipping out. That's not right, but it's less bad. I think that the reason that's not right is because our radar marker has an offset that is wrong. I think that it's trying to set itself to the middle position rather than to 0, 0. So if we set the scene view here. The problem is that it's tethered to the middle of the screen, as you can see, and that's going to screw it up all the time. We want to set it down here and then 0, 0 it. And that should do a better job. Yeah, there we are. New text. Great. And that's what we wanted. We wanted it to follow around any given object. Now, this particular object is so far away that it takes a considerable amount of time to approach it. But when you have these sorts of HUD elements, there are a lot of considerations to make. For example, why can I see it through my ship? Should I be able to? What happens when there's 50 of them? These sorts of considerations are what make games like Space Engineers so difficult. Now, in our case, the idea here is that you're not going to have very many of them, so we can play it a little bit fast and loose. But in general, we probably want to avoid having them overlap with the ship. The problem is that if we do a raycast every frame to try and catch to see whether or not we hit the ship, that can get a little expensive. So, you know, I'm not 100% sure that I want to do that, but let's go ahead and try it out. So what we're going to do here is have a raycast. First off, we're going to make our canvas element here. Public canvas element, canvas group. Protected canvas group, protected canvas group, get, if not canvas group, then canvas group equals get component canvas group, return canvas group. So much programming is done just by changing the capitalization of various things. We're also going to want to add in a required component type of canvas group. Perfect. So that way we can access the canvas group nice and fast. And then here what we can do is we can say ray equals camera dot ray from screen point to ray. And then we'll pass it the vector2 pause. And then we'll do raycast hit. And then we'll do if physics.raycast. I actually don't know whether or not there's a faster way to do this. It seems like there ought to be, but I don't think there is. We'll just pass it the ray and the out hit. And we'll give it a max distance of 100. 100 might be a little bit low, 200. And then we're going to go ahead and say that if something is there, we want to see whether or not it's the player's ship. So if hit dot, any hit against the ship will probably hit one of the sub-elements rather than the main element. But what we can do is we can ask it whether it's a child of the player's ship. And if we look into the ship, there should be a player ship. Is it the universe that's got that stored? That's a light. That's a universe. Okay, so no, we're not storing the player's ship right now as a universal constant, and we should. So we'll go ahead and do that. Public ship, player ship, and then up here, public static PC ship, because you can't name it the same thing. Get return live dot player ship. I forgot to put it as a ship. Why don't we go ahead and call it player ship, and we will call this one, come on, fix yourself. And we'll call this one underscore player ship. Boom. So the reason that I chose that is because it'll automatically patch that underscore right out. Come on. Oh, sorry, it's a ship.ship. Using ship. It'll automatically patch that underscore out, and it'll give us a nice... Seriously? I'm using the namespace ship and it still thinks I'm specifying the namespace ship? That's fucking dumb. Okay, you done? Jesus. Okay, so we're going to put the ship in there. And then over here, what we can do in our tracker is we can say if the hit is inside of the player ship. So first we're going to go ahead and check and make sure there is a ship. If universe.playership, then do this stuff. If there's no player ship, we're not going to friggin' worry about it. So if we're doing this raycast, we want to say if universe.playership.transform.contains. No, it's the opposite direction. So if hit.transform.inside. There is a function for this. It's like is member of or is contained within, something like that. Is child of. So if we are part of our, if we're hitting our ship, then we're going to want to vanish. And otherwise, we're going to want to appear. So else appear, else appear, public void vanish, public void appear, and here we say if canvas group, if canvas group dot alpha is less than 1, canvas group dot alpha plus equals time dot delta time times 2. And then up in the vanish, we just go the opposite direction. If canvas group is greater than 0, then minus equals. And that should kind of fade them in and out as they encounter the ship. So let's give that a shot and see whether or not it works. So as we move down here to see it, there it is, and as we move the ship in front of it, it vanishes. See? Nice, right? And we'll probably add more kinds of logic to that in the long run. But that is the tracking object. Now, the tracking object could have a lot of different reasons to exist. So what we're going to want to do is decide whether or not we descend from the tracking object for those, or whether or not those are add-ons that just reference a tracking object. And the answer is they should be add-ons. So we'll go ahead and separate them out. We'll have a different class for tracking objects in a HUD as logical HUD trackable objects. The only thing we really want to be clear on here, though, is that there are some things that we would like to add to this world to camera tracker, such as a maximum range. Public float max range equals 1000. There we are. That's fine. And then down here, what we're going to do is we're going to say if pause.z is greater than max range, then vanish and return. Lost signal. Now, I don't believe that we're going to start at anything near max range for this, because it should be within a kilometer. Or maybe it's not. Let's get a little closer and see if it appears. Obviously, we'll just adjust the max range, and we can adjust the max range based on your ship sensors, to the point where we could have like a static max range. We should be within 1000 by now. Apparently not. So, did I set it to 100 rather than 1000? Is that what I did? No, it's 1000. Well. Oh, it's in... it's in screen units. Okay, so we actually need to do is check and see whether or not target position minus ship position or screen camera position. There it is. So we're going to go ahead and say if camera.transform.position minus, I'll put another parenthesis in here, target.position.magnitude is greater than max range. There we are. That's going to be in world coordinates, which is going to make a lot more sense. Well, we're still outside of the range, but it should be less time until we actually encounter it. or not. I guess that wasn't in screen units, because that was the exact same response. Whatever. I can live with it either way. But if it was the same thing, we'll go ahead and use the way we had it before, because there's no reason to make more math for ourselves when we've already got it calculated. There we go. So because of that, we now have the ability to add these world to camera trackers to the world, and they will automatically keep us informed about what we would like to do. Excuse me, what we would like to do. Now, what sort of objects are we going to want to track? That is a good question, especially because we currently don't have any sort of text filler. So it's just like these text boxes stay hollow the whole time. Call them objective just by default. But what we would want to do is we'd want to make these things appear when you scan for them and then fade over time and stuff like that, which means we're going to need a new button. What button? Left click. We haven't assigned it to anything yet, and that's because we just didn't want to. I can always change what button scans later on, but for now what we're going to want to do is we're going to want to have a scanning device, a radar, which goes ping and then knocks over all of the stuff on my desk. Stop knocking over shit. That's high priority. So what we're going to want is a button that causes a radar ping, but we don't have a radar object on the ship. Now we could hard code a radar response into, say, the ship's console, the ship's control bed, but it's more in line with what we're trying to do, to have the radar be its own object and its own kind of component. So we're going to need to have a new ship component, which we are going to call a radar. We're going to open that up. We're also going to go ahead and open up another one just so that we can remember how they're programmed. You can see that this is in the namespace ship, and it has a controllable ship system as its basis. So we're going to do the same thing here. In namespace ship, and tab that in. And what we're going to want to do is, we do want the update. We're going to make it so that whenever you fire, the radar will ping the outside world. Now the problem with this is that the radar needs to know a couple of things. Wow, it's really being annoying here. We're going to go ahead and with a spherical pulse, where we're going to just go out and scan everything within a range. There's not going to be a visual for it yet. We're going to work on the visual later. But for now, we're going to need to know two things: the maximum range and the current range. So public float max range equals 10,000, and public float current scan range equals 0. No problem, right? And we'll need to know the float speed. How fast does this pan? So we're going to call this seconds to scan. And we're going to go ahead and make that 3. So what that means is that for 3 seconds, it'll go from 0. In 3 seconds, it'll go from 0 to 10,000. And that's the extent of that. So we don't want the current scan range. I lied. Rather than the current scan range, we're going to want to have seconds of scan. So seconds of scan and seconds to scan are going to be, you divide one by the other and you get the percentage. And that'll give us our range. So public float current range get return seconds of scan divided by seconds to scan times max range. And that's how we're going to do it. We're going to have it so that it will either be dormant or triggered. So public bool scanning equals false. And then down here in update, we're going to say if input.get mouse button down 0. We're also going to, do we want to, I guess this will scan when the menu's open is the problem. So we're going to want to make sure that that our controller system is the ship. We want to make sure the ship is in control. So ship control system dot queued controls. See this? So we're going to say if ship control system dot queued controls, ship control systems dot queued controls account, the topmost ship control system is in the same ship as us, then we're going to want to do this. So dot transform dot is child of universe dot player ship. Let's go ahead and make something that will actually do this calculation for us as a part of our, not our ship control system, but our controllable ship system. We're going to want to have something which says, are you part of the active ship? So public bool part of player ship. Get if universe dot player ship. If not universe dot player ship, return false. Otherwise, return universe return transform dot is child of universe dot player ship dot transform. There we go, and that'll be a little bit faster. And then we're also going to want to say that our ship control system has a couple of things here. So public static bool player ship in control. So if in control, so we want to say is if universe dot, get if dot.bow says have a good game dev stream. Okay, that's usually something that I hear when people leave. So did you show up a while ago and now you're leaving? Well, let's go ahead and continue on with our universe testing here. So if universe dot player ship contains, what did I make it? Was it not in the universe? Was it in? Oh, it was in the object. So it's part of this already. So if is in player ship, what was I calling it? Player ship in control. I just made it. It probably hasn't recompiled yet. Part of player ship. There it is. So if, oh, this needs to be an, I'm sorry, I'm thinking too hard and not actually doing stuff. So controllable ship system, system. Oh, no, wait, I don't need that. What am I talking about? So, yeah, so here is where I go. I need to pass this to queued controls. Okay, so I've been thinking around this too much and I've accidentally cornered myself a little bit, but it's no big deal. .bow is here, great. So what we're gonna do is we are just gonna check and see whether or not the queued control is inside the player ship. And to do that, we're gonna say if queued controls dot count equals 0, return false. If queued controls dot count -1 dot transform dot is child of universe dot player ship dot transform. Just return that. There we are. And that will tell us whether or not we have the player ship in control, or whether or not if the player ship is in control, then we'll have the freedom to respond to various commands. And to do that, we'll go back over to our radar and make it so that if we are in control, so if we're part of the player ship and we're in control, so if part of player ship and ship control system dot player in control, then we can do this part. So if we are supposed to be in control and we click the left mouse button, we want to emit a pulse. So scanning equals true and seconds of scan equals 0. Down here we're going to say if scanning seconds of scan plus equals time.delta time, And then we're going to just put all of the objects in inside of that scan range into the HUD elements. But of course, we haven't even gotten started on that. So how are we going to make it so that these things appear on the HUD? Well, we're going to need to know two things. First off, we're going to need to know the prefab for the HUD element UI, the box that gets drawn around them. Secondly, we're going to have to know how to find things to draw the boxes around. So those two elements are going to be the things we need. Now, one of those is already done. We just have to drop it into our prefabs list. So we just go like that, and that's fine. The other thing we need to do is we need to set that up as something that we know exists. So public world camera tracker HUD element prefab. So now that's all set up, as long as we remember to actually assign it. But we don't have a radar dish yet, do we? Let's go over to the ship and create a radar dish before we go any further, because I'll forget. So this is our current science scanner device. I screwed it up somewhere. This is our current science scanner device. And what we're going to want to do is... Seriously, did I screw up a whole bunch of shit? What? Get mouse button down, you idiot. So we're going to need to duplicate this scanner and create a radar scanner. And what we'll do is we'll just move it to a slightly different position so that we don't have to have two objects that are perfectly overlapped. Even though that neither of those objects is in a very good position given the position of the engine. So let's just go ahead and put it up here for now. Ah, that's not how I want it. There we are. That's fine. So that's going to be our radar. In order to make that the radar, we're going to have to remove the current script for making it a scanner and add in a radar. The good news is that the scanner is actually on a sub-object. So what we can do is we can just delete the scanner head's information entirely. Don't need it as a rotor. We don't need it as anything. We'll just clear it all out. And it'll be a static object. Volume. Oh, is this like a light? Yeah, I don't think we need to have a light on it either. We'll just delete that. And then drop in a radar scanner. There it is. We're going to need to have this as a sub-channel of normal or main or whatever it's called. I guess there's just leave it empty. That's fine. Yeah, I guess that's all fine. It doesn't really matter at this point. Yeah, that's all good. So we'll go ahead and set that up as our prefab for that object. Boom. No, don't overrate it. Just drop it into the same directory. I really wish that if you dropped something way over here in the middle of nowhere, it would realize that you weren't trying to drop it directly on something that's on the far left. Whatever, though. It works. So that should work. We should actually get a ping, but there's obviously no responsiveness to it yet. So what we're going to do is we're going to go ahead and in here, we'll just put a debug.log, and then we'll have it float % equals seconds of scan divided by seconds to scan. Clamp that. mathf.clamp01. That. And then here we'll just go ahead and say debug.log % plus % scanned via radar. And that way we can just tell and make sure that it's actually functioning. Hit play, let it spool up, and then we click, and you can see that it scans through the radar dish. And what we're going to want to do is shut this down when it hits 1. So if % equals 1 is greater than or equals 1, then I guess it doesn't have to be greater than, it's just going to clamp it, right? Then we're going to want to turn scanning off. We'll go ahead and put a debug line in here. Debug.log scanning radar scan complete. But we currently don't have any ability to search for the things that we would like to have pop up on our radar. We do have one category of thing that actually does have its own object. And let's go ahead and just clean this up while we're still paying attention. Thank you. And that is the little boxes that I've scattered on these objects. These little boxes all have a specific thing that they are, and it's in here. These individual chips are all objects that we want to have show up on our radar, although in this case there's an extra box on the far side, which I'll just delete for now. These are all things that we want, but the thing is that we don't want them individually necessarily. It would be better if, rather than having them all as individual objects, they were just a general point of interest. So what we're going to want to do is go through all of these harvestable objects and create various points of interest. So you can see that I already add them to the active list. All I need to do is get a list of locations and places for these things to be. So we're going to create a new kind of object, which we will call public struct harvest tag. And it's going to create a vector3, it's going to contain a vector3 and a name. So public vector3 position and a public string tag, like that. And you could do this with a dictionary as well. And in fact, since we're not writing it, a dictionary makes more sense. No, wait, we can't do it with a dictionary because we might have duplicates. And most dictionaries don't like that. So we're just going to go ahead and use our own custom setup. So public static list harvest tag tags equals new blah, blah, blah. And we're actually not going to do that way. We're going to do it with a getter and a setter. I don't think we do want to do that. We want to go ahead and public static bool dirty equals true. And what we're going to do is, if we are dirty, we're going to go ahead and regenerate it. Otherwise, we're not. So down here, when we change these, we're going to go ahead and say dirty equals true for all of these. So here we're going to say get, if not dirty, then return tags. Otherwise, we're going to want to calculate our tags out. Dirty equals false, tags.clear. And what we're going to want to do is come up with a list of locations that we can settle on. So for that, we're going to just go through all of our active objects and start adding them to the list of tags as we need to. For each harvestable object, obj in active, what we're going to want to do is first get the position of this object. So op equals obj.transform.position. And then we're going to want to go through existing tags and see whether or not any of them are within a certain range. So for int a equals 0, a is less than tags.count, or active, my bad. We don't have a list yet. So tags, yeah, tags.count. A++. And then the thing is, we have to remember these are structs, not classes, which does make things a little more complicated, but not too much. And I'm doing them as structs just because that's a really old habit I picked up. They could probably be classes without any real problems here, but whatever, we'll leave them as structs for now. And so what we're going to do is we're going to grab these and set them up as individual objects if there's nothing near them, if there's nothing similar to them. Otherwise, we're going to want to set them up as new objects. So bool absorbed equals false. If, I guess we'll just do, yeah, this is fine. If tags a dot position minus op dot magnitude, come on. I got really annoyed at the bus today, and so now my fingers don't work very well. Is less than the threshold magnitude, which we'll just go ahead and call 5 meters. Magic number in meters. Then we're going to want to combine them. 2 to close, combine. And in that case, what we're going to want to do is create a tag that counts the number of objects in that position and that sort of blah, 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 blah. So what we're going to do is we're going to say that position, we're just going to add in our name. Harvest tag equals tags a, tags a equals harvest tag. And we're going to say tag dot tag equals multiple objects. But we only do that if we need to. So if tags a dot tag does not equal multiple, then set it to multiple. And also set it to absorbed. We're not going to move it because it's a small range, so I don't really care. But down here we're going to say if not absorbed, then we need to create it fresh. So harvest tag equals new harvest tag, tag dot position equals op, and tag dot tag equals name. It's going to be the name of the object, which is obj.name. And then down here, return tags. We need to add it. Tags.add tag. And that will create a list of all of the things we care about, but it'll cluster anything that's real close together so that we don't get like 10,000 icons overlapping each other. We'll still get some overlaps, but it's not too bad. So with that in mind, our scanner, here it is. We got too much shit open. Let's close some of this shit down. There. So now our scanner is going to request that list of tags and then create a UI tag for each of them. So basically we're going to take that data and we're going to create UI for it. And in order to do that, oh, this is the scanner, not the radar. Damn it. I accidentally closed the radar. Let's radar. Here we are. So what we're going to do is we're going to try and find anything that is within, anything that's scanned. So we're going to go ahead and say list harvest scan, harvest tag, tags equals harvestable object dot tags. There we go. That'll get us a list of all of the tags we might need. What we need to do is create a HUD element for each one of those objects that's within our range. Now we're going to want to track all of the tags that we create. World to camera tracker active tags. That can actually be static, to be honest. We don't really care who put it up there. We just don't want to duplicate them too much. So for each harvest tag, tag and tags, we're going to see whether or not there is an active tag for it. So bool exists equals false. For each world to camera tracker in active tags, if tracker.name. Well, here's the thing. We actually need to get rid of any tags that are no longer valid as well. Okay, so we're going to need to have two lists. a list of harvest tags and a list of active tags. Active tags used, new list there. And what we're going to do is call these used tags. Here we go. So what we're going to need to do is if we find a tag that matches and is the right place and all that stuff, we are just going to keep using it. But we'll need to remember to delete the ones that no longer match because they probably had their objects removed. Or we could add in a self-destruct mechanism where if the object they're tracking goes passive, they go away. That would make sense, except for these tracker tags. I've just screwed everything up because this doesn't pass us a transform, it passes us a position. So we'll go ahead and make it a transform. So here we say harvest tag dot position equals obj dot transform. There we go. And because we're tracking the transforms, we'll be able to self-destruct if the transforms stop happening, which we can do by opening up that tag. And here in update, we'll go ahead and say, if not target, then destroy ourselves. That way, well, the other option we have is these things often don't get destroyed, but they get disabled. So we're going to say if not target or target.active. Target is active. So there. So we're going to self-destruct every time we find something we don't like. And over here in the harvestable objects, radar, here we are, the radar. So we're not going to worry about used tags. They'll self-destruct on their own. But what we're going to need to do is keep track of the tags we are using. And we're going to say that if the active tags contain the same transform, so if the tracker dot target equals our tag dot position, let's go ahead and rename that because that's we're going to want to have that be named something besides position, like transform. That was the wrong way to do it. Refactor, rename, transform. So if the target equals the tag, then we've already got it. So we say exists equals true and break. Down here we say if it doesn't exist yet, then we need to make it exist. So in that case, what we're going to want to do is just create a new prefab for it. So world to camera tracker new tracker equals world to camera tracker dot instantiate, and then we pass it the prefab HUD element prefab, and we don't really care where it is or anything like that because that'll all get put up on its own, but it does have to be within the universe because that is the canvas that will be displaying it. So we're going to have the universe.transform, universe.live.transform. It's going to have to pop up in there so we can see it. The new tracker will have a object assigned to it, which is going to be the tag.transform. And we're going to go ahead and name the new tracker to match the name of the tag. And we're also going to want it to have it name itself. So in the first update, so void start list text. Okay, so I have to include the UI. So what we're doing now, I've kind of been wombling and not talking too much because I've been going on in my head too much. Basically, we're creating trackers for every single trackable object that's within a range of your radar. But in order for us to really cement that, we need these things to automatically fetch all of the text boxes that need to be changed to match the name, and then match the name. Get components in children text for each. Text b in boxes, b.text equals name. So that should do the trick, no problem, except for we need to add this to our list of all of our tags. Active.add tag. Problem with that is we're using a for each, so we'll have to break this for each and turn it into an if. For int b equals 0, b is less than active.count, b++, obj equals active b. I don't think active is right though, is it? I should have named this something else. Let's name it something else right now. Oh, no, that's correct. I'm in the wrong file. Oh my god, did I just fuck everything up? I just fucked everything up because I'm in the wrong file and I didn't even notice. Undo all of this shit. No wonder I was getting errors. I'm in the wrong file, idiot. I really wish that I weren't quite so stupid. Alright, so this is where we do all of our radar stuff, in the radar file. Fucking brilliant. This is where we drop all of this crap. So, new tracker equals universe.live.transform. New tracker.target equals... Okay, so hold on. How much did I break here? So I'm not sure I broke anything. I think I caught it in time. I go through all the tags. If they're within 5 meters, I reuse it and set it to true. Down here, if that's not absorbed, then I create a new tag, and I set these values, and I add them to the list of act. There's what I did wrong. Perfect. Because obviously, that was where I started to do it in the wrong file, and here is where it should be. And this is not active. This is called something that makes more sense for the location. Active tags. Much better. Alright, so here we are. We're going through all of these tags, and then we're creating trackers if we need them. But first we check and make sure that no tracker is currently tracking that tag. If that tag is already being tracked, we set exists to true. If it's not already being tracked, then we create a new tracking tab, a new tracking UI element, and put it in the universe. We assign the name, we assign the target, and we add it to the list of things we're tracking. So I only screwed up right at the end there. I just clicked on the wrong spot when I was finishing up. And that should be okay. But, yeah. There's no for each here screwing things up for us. Great. Okay, so that should be a radar tag. The only problem is right now, I'm not actually checking to see whether or not the transform is within range. So we're going to want to make sure that the tags are actually possible. So float range equals tag.transform.position minus camera.position .magnitude. And that'll get us the range to the tag. And then what we need to make sure that that's within the range that we're trying to reach. So let's save the range we're trying to reach. Float range equals % times max range. So here we're going to say current range. Wait, we already do that. We already have a current range. Yeah, current range. There it is. So we'll just say if current range, if this number, which is how far away it is greater than our current range, then we'll just continue. And we won't worry about that tag because it's outside of our current range. Otherwise, we'll do it just fine. Now, there is one last thing I wanted to do, and that is... Oh. What's going on? What the fuck was that? I'm in the middle of programming it? I don't know. So there have been a couple of problems, presumably because I screwed stuff up. So let's go through them. Transform.position, you idiot. Camera is obsolete. Because the radar doesn't understand what the camera is. I shouldn't be going against the camera. I should be going against the radar. Got my brain all screwed up here. Dotbow says he once accidentally deleted his entire graduation project. That's pretty bad. I didn't accidentally delete anything, but I did get pinged by some weird shit. So this is new tracker, not tag. Oh, this is text array, not a list. Fix all the problems? Okay. So the logic here should be sound. I just implemented a lot of crap all at once and got myself all talked out and screwed up. But I think everything should be okay now. It'll create these things as it scans away. But what we need to do is, for the last thing, we're going to be changing the pop-up radar marker to be transparent at start. That way it'll be like whoom, 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 as it pops into existence. Let's give it a shot. Okay, so if I were to click, boing, it broke. My guess is that I forgot to assign the radar head the proper prefab. Yep, I forgot to put the prefab in. You gotta plug things in before they work. So, bing, wow, see? Neat, right? Let's go over and take a look. Now, these are, I put in a lot of them. Obviously, that's not how many there would normally be. I just kind of been scattering them around at random. And you can tell that if we move, see, they don't interfere with our seeing our ship. Look at all of them. Perfect. And in that way, you can hopefully keep track of what's going on. But you can see that some of these are acting erratically. The problem with that is that they're actually correctly placed, but they're behind us. So we need to have a special case where when they're not on the screen, they go away. And to do that, what we're going to do is we're just going to go ahead and make this world to camera tracker not work if the Z value is negative. We'll go ahead and make it less than 30. Well, less than 10. No, less than 50. Now, the reason for that is because once we get within range of the camera that we're that close, we don't want them to keep popping up. Dotbow says he does a lot of backups now, and I agree. Backing things up is a necessity. I have backups of this as well. So now we should see them fade away as we get close. Well, they certainly do fade away, but they stop tracking when they fade away, which is actually not what I want. So we're not going to return here. But we are going to just vanish twice. That way they'll keep tracking properly as they disappear, rather than freezing on the screen in a weird place. No, we're gonna crash. Kabonk. That's fine. move it. So they're tracking versus the camera right now, which might feel a little bit odd, and I may change that later, but that's basically correct. So that is going well. There are a couple of things that I want to change, and they're all the fact that this has a lot of extra collectibles, and we need to delete all those extra collectibles. Come on. I think that those only have the correct collectibles. All right. So now when we click, we see a nice trail of collectibles waiting for us. And you can see how they're all tagged multiple. That's because all of them exist. Now what I can do is I can make it a little bit more complicated, either by spawning these in with a randomized element, or by having the harvestable objects delete themselves with a certain percentage of a chance. So to go ahead and reflect that, we're going to go ahead and say public float delete on spawn chance, and we'll make it a 0.7 by default. We'll say if delete on spawn chance is less than 1, and mathf.random random dot value is less than delete on spawn chance, then delete. What the heck? That was odd. Destroy this and return. That way, there should be a chance of not having all of those objects in every single place. Bing. See how some of these now say CPU and additional chips? That's good. Those places have had 3 out of the 4 objects deleted, whereas these multiples still have several of the objects in place. Grab it. Oh no, I screwed it all up. Oh, I'm getting real hungry. And you can see that as we back off now... Oh, I didn't get them yet. I screwed up that. I need to fix this arm so that it works a lot better. Alright, so now we got it. We're going to back up, and we should see that the multiples tag is gone. And if we click, it doesn't come back. Also, if we keep clicking, we don't get loads and loads and loads of extra markers. So just taking a look here at the HUD, and you can see that we don't have 10,000 of these. We've only got 1 per object. The other thing I'm going to do is I'm going to change the scanner, the radar dish, so that instead of scanning real fast, it actually scans quite slowly. And the reason for that is that way you'll be able to see the things pop in as they go. There we are. That's better. We've also got this guy. There's nothing actually assigned to this right now, but you can see that it works. All right. Well, I'm getting hungry, and it's actually been going on for quite a while, this particular stream. I call it a success, I guess. So I'm thinking about stopping soon. I'm going to take some screenshots. I still need to get a new GIF system. Unfortunately, the old GIF creator I was using wasn't actually capturing these lights, so you couldn't see any of the engine effects. And I haven't found a new one yet. I have to look for one a little bit more aggressively. But, you know, that is the nature of the game. So let's go ahead and screenshot. All right. I'll go over here and tell people about it. So here we'll go ahead and say radar implemented, also fixed vertical, freeform, freefall piloting. Paste, IndieDev. That's not how you spell IndieDev. That's how you spell IndieDev. And then here I'll tell this guy, that's why you need a human. Paste. All right, great. Let's get that out on a tray. All right. Sweet, that's what he says, isn't it? No, it's nice, nice. Anyhow, I'm going to go have dinner, and thanks for stopping by, everybody. I will see you all on Sunday if you care to stop by. Same basic time, same basic channel. And hopefully the bus will be running on time that day. Have a good one.